Hi everybody, this is Nafish. Today we are going to go over NumPy matrix operations, and this is just for the beginners and whoever is getting started with NumPy. As usual, we are going to open up a Jupyter notebook, and then we need to import NumPy as NP. This is most people use NumPy as NP. You can give some other name. Let's run this cell. And then, so I have written down what are the exercises we're going to go over. So first, we are going to go over the dot product for scalar, array, and matrix. So we first import NumPy as NP, and then NP dot, and then let's say 3 and 4. So this is basically the dot product of two scalars, 3 and 4. Let's see what we get. So we get 12. We can use 30 and 4, which is going to give you 120. So this is like the dot product of a scalar is just a multiplication. Okay. So let's move on to arrays. So we first need to declare two arrays. Okay, so x is, just give it a name, x and y. So x is equals to np dot array, and then inside the array, I'm just assuming like four list of four numbers, 1 2 3 4. Okay, and then copy this part and paste it into y variable, and let's change the numbers here. So 10, let's give 10 20 30 and 40. Okay, and then we have two arrays, okay, x and y. Then we're going to get the dot product of these two arrays. So let's see what is the answer. So np dot dot and then x and y. So let's see what is the answer. That is 300. So how we're getting this 300? Okay, so let me explain that. So this is basically the array operation. Dot product of the array operation is like, element by element multiplication. So you multiply 1 times 10, then you add 2 times 20, and then you add 3 times 30, then you add 4 times 40. So basically 1 times 10, and then you have 2 times 20, then you have 3 times 30, then you have 4 times 40, and basically you do the addition. Okay, and if you do add all these numbers, you're going to get 300. Okay, so this is like element by element operation. Okay, so the array dot product is element by element operation. We need to remember that. Okay, so let's move on to matrix. Let's create two matrix. Let's say x is np dot array, and we know that matrix is two-dimensional or multi-dimensional. So we have, let's say the first row is 1 and 2, and then we have the second row, which is, let's say, 3 and 4, and the entire thing will be in a bracket. For the matrix, we need to put everything in a bracket. Okay, and then you create the y variable. So y is np.array, and let's give it number 10, 20, you have 30, and you have 40, and let's visualize this as well. Okay, so print x, and then print y. We want the space in between, so let's say, so this is going to create a new line. Okay, run it. So our first matrix x is 1 2 3 and 4, and the second matrix is 10 20 30 and 40. Okay, and you see like the first row 1 and 2, and then we use a column. So this is the third row, second row. Okay, so if we want to add more rows, we're going to create another column, another comma, and then we're going to give some numbers like, let's say, 5 and 6. Okay, something like that. So for simplicity, let's have 2 rows and 2 columns. Okay, and then do the dot product. So I'm copying this np dot right here, and this is going to give you the dot product of this matrix. Okay, so we get 70, we get 100, 150, and 220. How we're getting this number? Again, this is, we're going to, for matrix multiplication, we're going to take the first row. So first row is 1 and 2. Okay, and then that's going to be multiplied with the first column. So times 10 plus the second one is 30, so 30, so you get 10 plus 60, which is 70. Okay, so you see the first element is 70. So how about how we're getting the second element, 100? So this is the same row, but the column will be 20 and 40. So the column value is 20 and 40. So you are going to get 20 plus 80, which is 100. Okay, so this is how you're getting the dot product from a matrix multiplication. Okay, now let's what we want to do is find the transpose, inverse, and determinant of a matrix. So for that, so let's say our matrix is X using the one we declared before, and the way we're going to get the transpose is just X dot T. Okay, so you see 1 3, let's write it in a different cell. So first we have X, and then we do the transpose X dot T and run it, and you see we get 1 3 2 and 4, which is, so in matrix when we are going to do the transpose, the rows will be the columns for the transpose matrix. So 1 2, which is the row, is the column in the transpose matrix. Same with 3 and 4, which is now the column. Okay, we can do the transpose in a different way as well, which is X. We can do NP in NumPy. We're calling the NumPy, then transpose. Okay, and then we're going to transpose X matrix. So put X down there, and you see we're getting the same answer as X dot T. Okay, so this is another way to do the transpose. Now do the inverse of this matrix. So to do the inverse, what we need to do, we need to call the NP NumPy, and then we have a function called lin. So it is a linear algebra thing. So lin alg, that's how we call it, and then we do the inv. Okay, and we're going to do the inverse of matrix X. So let's run it, and this is the inverse of the matrix X. We can do the same thing to calculate the determinant. So instead of int, we're going to do the det and then X. So let's find the determinant. The determinant is this guy. Okay, so this is how we can do the transpose, inverse, and determinant of a matrix. Now we can do other things with NumPy, which is matrix addition, multiplication, division, and subtraction. So let's say we have a matrix X and we have Y. Okay, so if we have X and Y, we can add these two matrices, X plus Y. The number of elements needs to be same. Okay, so we have 4 here, we have 4 here, so X plus Y is going to be element by element addition. So let's see what we get. We get this guy. So 1 plus 11, 1 plus 10 is going to give you 11, then 2 plus 20 is going to give you 22. So it's an element by element operation. So we can do the same thing. We can do subtraction now. Okay, so X minus Y, and it's going to give you the same way we're going to get the values as well here. Okay, just the element by element operation. We have to remember that we can do a multiplication, X times Y, and we get 10 40 90 and 160. But if you remember, we had the dot product here of these two matrices. You see the numbers are different. Why we are having different numbers in the dot product and this multiplication? You see, when we do the dot product, we get a different number. So in the dot product and the multiplication here, they are different, because we are multiplying element by element here when we're doing this multiplication operation. But when we're doing this dot product, we are going to multiply as well as do addition. So this is we can also use another thing, which is np dot matmul, which is the matrix multiplication X and Y, and let's see what we get. We get 70. So so we are going to get the exact dot product. We're not going to get this element by element operation here in the matrix multiplication. We have to remember that. Okay, so let's see what else we need to do. Okay, we also need to do, so how about when we have a matrix X, how about we want to sum of all these elements here. So to do that, X dot sum, and then it's going to add up all these elements. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So it's going to give you 10. Okay, so if we're going to do column wise, then we need to do axis. We need to call axis is equals to 1. So it's going to do the addition column wise. So 1 plus 2 is 3, and 3 plus 4 is 7. So it's going to give you 3 and 7. You see, 3 and 7. If it is row wise, then you're going to get a different number, 4 and 6. Okay, and we can also find the diagonal values. So X dot, let's see the X first, and then so that diagonal values will be 1 and 4, right? So X dot diagonal, and then press it, you get 1 and 4. So you're getting the diagonal values, and if you're going to get the sum of it, then do the sum, you get 5. Okay, now let's solve two linear equations. So let's assume, like, we have two linear equations, just giving some random numbers. Okay, so 2x plus 3y is equals to 20, and then we have 3x plus 4y is equals to 30. Okay, it's creating two equations, and now we need to write this in a matrix form. So np dot a, then let's say left hand side. Okay, left hand side is equals to np dot array, and then let's write it down in a matrix format. Okay, so we have, in the first one we have 2 and 3, so 2 and 3, and in the second one we have 3 and 4. Okay, so this is our left hand side, and our right hand side is equals to, we have 20 and 30, so 20 and 30. Okay, now if you're going to solve this linear equation, np dot solve, np dot linear algebra lin alg, and then dot solve. Okay, and then we need to write down left hand side, then right hand side. Okay, so this is going to give you the solution for x and y. Okay, I think I made some oh, so since it was a matrix, I need to put another bracket, right? So run it. Okay, so this is the solution for this, for x and y. Okay, so we can resolve the linear equations by formulating a matrix inside an array, and then call the lin L and then solve